Okay, this is the M1 paper from October 2020. This is question number 1, which is a collisions question, momentum and impulse. We're going to be using the conservation of linear momentum in this one. As you can see, I've just got myself started with drawing out the beginnings of the diagram. Let's see what they tell us. They tell me that two particles, P and Q, okay, so we've got P and Q with masses M and 2m respectively, moving in the same direction along the straight line when they collide. P is moving with a speed of 4u and Q is moving with the speed of u. So this is before. What then happens is immediately after they collide, they're both moving in the same direction, excuse me, and Q is going to be going 4 times as quickly as P. So bear with me a second while I just copy this to make it easier for me to have a neat diagram. So after, what's going on? Well, these two speeds, they've told me they're going in the same direction, and they've told me if I decide to call that one V, which I'm going to, then this one has to be 4 times as big, so it has to be 4V. Now we can see the question there. It says find the speed of Q, this one here, immediately after the collision. Yeah, I've got enough information to be able to do that, so let's crack on. Using the conservation of linear momentum, I always write the formula down. It helps me to just remember what's going on. The initial velocity, the initial momentum, M1U1, M2U2, is going to be equal to the final momentum, M1V1 plus M2V2. The momentum is conserved, conservation of linear momentum. So let's put the information in. So M1U1 is going to be M times 4U, and M2U2 is going to be 2M times U. That's the same as MV plus 2M times 4V. Tidying that all up, I've got 4MU plus 2MU, 6MU, is equal to MV plus 8MV. That's equal to 9MV. We're going to cancel out the M's, and if we divide, we get that V is 6U over 9, that's 2U over 3. That's not what we're actually asked for. We wanted the speed of Q, so speed of Q, that's my final answer, is 4V, so it's 4 lots of 2U over 3. So it's equal to 8U over 3. That's my answer to part A, which is the speed of Q immediately after the collision. Now it says find the magnitude of the impulse exerted by Q on P in the collision. We remember that the magnitude will be the same if it was exerted by P on Q. It doesn't matter which way round you do it. One might be the negative of the other one. They want the magnitude anyway. So I'm going to consider that particle there when I'm doing it. So I've got this situation and this situation. I could just as easily, in this case, because we've got all the information, have done it with that one there. Sometimes the question will define which of the objects, which of the particles you're actually looking at. So for part B, I'm going to tell them, considering P, impulse is equal to M V minus U, change in momentum. So in this case, it's going to be equal to M V minus 4U, or in other words, it's going to be equal to M. We've worked out that V was 2U over 3 minus 4U is going to give me a negative impulse of minus 10 MU over 3. That's showing me that the impulse is going to be going in the opposite direction there. So I'll say that that's part C. I haven't answered part B properly yet though. The magnitude of the impulse is 10 mu over 3. So that's the answer to part B. But then part C, impulse is in opposite direction. And that's given by the fact that it worked out to be a negative if I was taking that way as positive, which I was because everything was positive in that particular case. Okay, hopefully that makes sense.